Hi guys, I thought I'd start a new little series of videos under the heading of practical electronics, or maybe just electronics for fun. Anyway, there's a lot of videos out there, but many of them are very technical, lots of math and theory and stuff. And if you're doing electronics as a hobby just for fun, that's just not something that you really want to do. So I thought I'd do some videos showing you how you can just do things in a practical way and not having to do too much math and too much theory. I wanted to show how to make PCBs as well and to how to lay out the circuits using KiCad. I've done a little bit of that before in some of my other videos, but I thought I would do a little bit more extensive and break the videos into pieces. So editing the circuit and creating the PCB and then actually making the PCB and using photoresist and all that kind of stuff with a little bit more detail than I've done before, and also it'll be broken out as separate little videos rather than having to watch um, the parts that you may not be interested in. Anyway, so let's get started. Okay, so I'm used to KiCad, so we will use it. It is open source software, and you can actually find it on the internet at KiCad.org. So there we are, and you can download it. It is open source software. If you like it, you can donate to it to help its development, but you will find that it is available for a wide range of Linuxes and even for the Raspberry Pi, and of course Windows. So when you install it and open it, you will be greeted with this interface here. And normally you would either create a new project or open a project if it's not open already. In my case, we are actually using this invert PSU project that I'm working on. We're going to be developing a PCB for it. What it is a buck regulator, and it is based on an LM2596, I think it is numbered as, and it actually takes in 12 volts positive and outputs plus 5 volts and also minus 12 volts. So we'll have a combination there of plus 12, minus 12 and plus 5. I've got some projects coming up where we can use that if it works. This is actually the first test that I'm doing on this, but for the purposes of developing the PCB, this is why we're doing these videos. So this is just an overview that we're going to do. This is not a full KiCad tutorial. There are others out there already which do a good job of that if you search for them. Okay, so just to get a little feel for how to enter components into KiCad, we are going to add an LED to this circuit, and in order to do that, we'll add a symbol. We're going to be needing a resistor, and we're going to be needing an LED. We're going to hit the R key to rotate it. That's good. All right. Wiring tool. Okay, let's increase the size a little bit so we can actually see what we're doing. Okay, now this is 12 volts in. Selection tool. Well, actually, first thing, let us name those, annotate. So this has become D2, and this has become R4. Let's make that 1K. And the other thing that we now have to do is we got to tell KiCad the footprints of these components. So we can edit the footprint here or hit the uppercase F. We will go to the library and we are looking for a resistor, and it's going to be an SMD resistor, and we are looking for the size that I have is 805 rather. That one will do. Sometimes there's one there that says hand solder, which is what I always select because we're hand soldering. Okay, so that one is it. Okay, resistor. Alright. So this is to tell the PCB editor, you know how big to make the pads and all that kind of stuff. This one, so I can hit F, add the footprint. And now we are looking for an LED, and it's also going to be an SMD, and it is going to be also an 805. Okay, so that's kind of what you do with the circuit. There's only one other thing to mention with KiCad is you have to, we have selection mode, yes, you have to add these little flags to it. These power flags, they come from over here on the side there. Power symbols. Well, you select the voltage or whatever you want to use there. There it is, power flag. And unless you do that, it will always complain that you don't have power connected or something like that. So there's a power flag there, power flag here, there's one there, and there should be one. But that's an output, so it doesn't need that. Alright, so that's basically what you do there. Then you can click on this little icon here, and again I have to move this from the main screen to down here. Again, you can go to view, zoom to objects, and this is what I have already laid out. But now when I go to over here, you'll see that I have two new components to put somewhere. So first thing I will do is I will use this over here. There are some useful things here, like you can hide the pads, or you can we don't have vias. You can actually show how the traces are made up. These are all the little bits and pieces that make it up, so you can actually click on it. Quite often in KiCad it's kind of a quirk when you are creating traces, and you might delete a piece of it and reroute it a bit or something, and it leaves little bits behind that are not connected, it says, and they will come up when you say run the design rule checker. And you see there'll be errors. We actually have two errors because we haven't yet connected the resistor and the LED yet, and when you do that, it will you can kind of tell, there's some lines over here. All right, this is plus 12 volt here. Yeah, so this resistor here, see what I mean? I haven't got, no, now it is selected. I'm going to rotate that R key, and for move, let me see now. Go there. No, I rotated that one 2 times R. Now it is in the right direction. Let me see. Alright, so now wiring tool here, or trace, or whatever you want to call it, and we're going to go from here okay. Now by default these are thick traces for the plus 12 volts. Use custom values, doesn't have to be more than 0.75 millimeters for an LED. No, I don't like that. That's a little bit better. I want a bit of clearance for that capacitor there. Okay, I think that should do it. Okay, no errors, no warnings, we're in business. So many of these components might be kind of unique, and so you'll have to find the footprint that actually is correct for them. So let's say, for instance, this diode over here, the 1N5822, and if we go to footprint, we see that we have selected the SMD SMA hand soldering footprint. And one thing is that obviously we have got diode SMD selected, and we have SMA for hand soldering. So how do I know that this is an SMA? This is where these things come in. First of all, I have a set of calipers here. I prefer these mechanical calipers on account that I also have some over there, you know, the typical digital ones that everyone uses. However, the batteries run down in them and everything. This thing doesn't need batteries, and it is very easy to read. So you can actually take a component, you know, like this one here, and you can actually go and, well, now let's take this little one here. Let's zoom in. They're pretty small, so you can actually go and oops, I always get caught. Okay, so that's the size of it, the length, and if you look at that, it is 1, 2, 3 point, and then you look at the little red lever, the pointer here for millimeters, 6. That's 3.6 millimeters long, and so you can kind of so for some components you can kind of go in and you can use this measuring tool over here. And then you can sort of, like, if you want to know if the pads are long enough, you can click on it and then you can actually move to the end of the pad. So this particular pad here is in total 8.5 millimeters long. So that's quite often how I determine if I don't know what kind of pads a component needs. I'll find one that looks about right, and then you will find over here usually there's a whole bunch of different sizes. Like if you look at the top over here, 2010, 2114, and if I go up higher, 1210, 1206, 805, 603, right down to 201. However, for those components here, that is not really necessary to do as such. I'm going to go cancel here and turn off the display. That's where these things come in. Let me zoom out again. So I have some components here which we will demonstrate that on. I have these different rulers here. They have some duplication, but it's kind of interesting. This one here is one of the most useful ones. Again, in the links, on the comments, there will be a link to where these things come from if you want to purchase these kind of things. On the back side, there is some more information. So, likewise with these, they have different widths of things. They've got little holes in them here, These are mils, and on this side is millimeters. So sometimes you have a component like this resistor here, and you're thinking, how thick are those legs? Of course, you can measure them with the calipers, but it is easy. This one here has got a good section for that, so you can go, well, it doesn't quite fit in 1 millimeter, to be too tight. 1.2 millimeters, that's perfect. So that's where these things can come in as well. Of course, it's, it's got rulers on the end. I don't use inches. Alright, so if you want to find out what these components are when you're laying out your PCBs, I find this one here, and which one is it now? Well, they're all useful because they have different different types of pads on them. But I think let's start with this one here, and again, let me zoom in. Another thing that's useful on these is they have where the anode and the cathode is, in case you're forgetting, and the little LED. See, the long lead is positive anode, short lead is the cathode, so that's useful too. It has the American wire gauge thing here, so if you got a piece of wire, you can actually poke the wire in there, and then you say, oh look, this is 18 gauge. We just determined that that's like 1.2 millimeters, and then you can actually use the other one there to see what size drill you might have to use or something like that. You can work it out. Alright, so let's say you are, let me move these guys a bit over here. So if you're wondering what this is, it's actually on the other ruler here. So you line it up with a likely looking track here, and then you say, yep, that's the one. So then in KiCad you're looking for SOP 16 for this one, and likewise for this little one over here. We're looking for an SOP 8. Of course, after a while you kind of know what they look like. You wouldn't have to do that, but I'm just doing this for demonstration purposes. Here we've got a little 5-pin. If I can only get it to lie down properly. Yeah, that's it. And so there it is over here. Fits that one over here. But in actual fact, there is no lettering for it. I think it's an SOT25 or something. And let me see if the other ones, one of the other ones has something like that. Aha, there it is. Yes, indeed. I guessed correctly. This one over here actually has the lettering on it. Usually the last number on those SOT things is the number of pins. So this one over here said SOT23 for the 3-pin one. And this is an SOT25. You see there it is over here. Yep, so that would fit on there. So this is kind of how you can work out with these little rulers here. This is what I do. I work out what the component is like. And then we have, let's see if I can get both of those in there. Big resistors here. This is the resistor section. So this one fits on a 2010 or 5025 metric. You can just double check. Here is a small resistor, and that fits on a (0.805). But what I usually do is I go one size up, because if you use 0.5, this is okay if you're using solder paste and it gets heated and it just melts onto the pads, but there's not much room for hand soldering, because you would like to get your soldering iron right next to it to heat up the component and the pad underneath. So I would use 1206 for that, so you have a little bit of shoulder room. Again, this is why this is good to have. This kind of component here, I'm not sure if people are still using it, but you see them on slightly little older circuit boards. It's actually like a diode with its legs missing. And I think I would select this Mini Melf, it says, or S0080, something like that. That would fit on there. And now when it comes to capacitors, could actually put this on a 1206 actually. Come to think of it, these kind of capacitors use the same size as the resistors. This SMA SMB thing is more for these kind of capacitors. This is a tantalum capacitor. See, this is an SMB. And here is a diode. Diodes tend to be also go onto these kind of pads. SMA, I think I would put it on this one on SMB, so I have plenty of room to solder it. Here is a bigger one, but it would still fit on an SMB, or on this one be that different type as an SMA. This is a really big one, SMC. And then you've got like MOSFETs. So that is a D-pack, is it? Yeah, that would fit on there. And here, this one, it's got a better solution, I think. Yeah, that fits better. TO252-3. TO252-3. That fits on there. Anyway, so I thought I would just highlight what I do, how to find the sizes of these components. Okay, so once we go to the PCB layout designer here, what I do with these PCBs is I do not connect any of the ground connections because I'm using a single-sided PCB. If you've got double-sided ones, you could potentially put a ground plane on the other side of it and connect them to that, but we're using single-sided, so it's all going to be it shows it all to be on the top, but we actually cheat. What we're going to do is we create a PCB just on one side, and we will put the through hole components actually on the other side, but the SMD components are going to end up on this side, which is the front side, which you will see once we start building the thing, if that makes any sense. So when you look at the 3D, you can kind of go all three. You see, it thinks that all the components are going to be on the one side, but that's not actually what we're going to be doing. We're actually going to be putting these capacitors, that one, and this one, not this one, this is an SMD component, that's actually going to be in that side, but these capacitors here, the trim part and that, and in fact there's a two toroidal coils there, which it doesn't know how to display, so it just shows you the outline. They are all going to end up actually on the opposite side. So as we are concerned, they're actually going to end up on this side, since they've got through holes. See, we're going to put them over here, and this is going to be we're going to use this as the top side of the board in actual fact. And that's okay, because these surface mount components are not very high, and we use little standoffs. This fuse too is going to be on the other side. So this, that capacitor, this one, and that one are going to end up on the other side of the board. But KiCad doesn't know about that, because we are sneaky. Alright, so if that makes any sense. So what we do with these with this board is you can use these things over here in order to, you can click that and then all the pads are outlined. You can click this one and all the vias would be outlined, but we don't have any. You can click this one and all the traces are showing outlines. This can be handy sometimes, because you can see the traces are actually made out of bits and pieces, especially where I put double traces on top of each other in order to make these areas. Theoretically, it should be possible to use zone fills for those too, but for some reason, whenever I do that, it always complains. And probably due to me not knowing exactly how to tell the main outline to ignore them, I don't know. But so I just use multiple traces on top of each other. That's why they're kind of weird shapes sometimes. And you can see that when I go like that, you can see they're all bits and pieces. This is a little bit narrower than that one, and so on, to make clearance for stuff and what have you. Okay, so by the same token, you can turn the outline on or off. So if I turn the outline, and of course over here you can say fill all zones. Once you make changes to it, you got to let it refill. And you can see that the ground pins I do not have connected anywhere, because I do a whole fill, and you see the outline of it here, those red lines there. That's the outline fill. It fills it up and automatically connects all the ground pins together. So what you need to watch for is that these ground connections have sufficient width in order for current to flow out of that ground pin into the other ground outputs or inputs, whatever. So as you can see, this is wide enough here. It can get around here. This is wide enough. That here plus the one at the bottom here make it wide enough to get to all the ground pins over here. And this one over here, it actually goes through here. This is ground, so this is an important ground spot on this inductor here. This is the main buck regulator inductor. So that has sufficient input there, including that +5 regulator, which should output at least 1 amp. And so it goes on, and there is ground on these capacitors, everything. So this all works. So I actually made the board a little bit wider and a little bit bigger in order for that to happen. So that's what you got to watch out for when you're using the ground plane instead of traces. So the next thing to do, or the thing before you even do the board, you'll find under the file menu here, there is a board setup. It took a little while to come up. Where you can set certain settings. The things that only thing that I want to mention here is the place where you can actually set up the trace widths. For hand soldering and for homemade PCBs, I like the track width to be at least 1 millimeter, and a VS size if I use them. If I have to put something on the back of the board like a jumper wire, I use these VS for those. It thinks there's going to be a trace on the other side, but it'll be a piece of wire. I set those to a minimum size, 2 millimeters, 1 millimeter hole, all that kind of stuff. Then I have a couple of things to find here: alt power and power. You can just hit the plus button over here and add them, and you will find that it'll list all the net classes from the circuit. Let me see if I can make this a bit bigger, and you can actually assign those to the various nets. And for some reason I created alt power, but I didn't actually assign it to anything. I should have probably, but I'll show you. You can actually override the size in any case. But so the power line, I made it at least 0.5 millimeters clearance. I made the track width default to 3 millimeters, and so on. And then the net that says +12, -12, and ground, I will assign them to power, and there's a couple there from that are important to C6 to pad 2. You can actually see them on the circuit there. I also told them to use power. So is there anything else there that is important? There is, of course, you know, the layers of all sorts of stuff which I don't actually have to deal with. I just leave them alone. Okay, because I cancel. So that actually means that when I hit like one of these, if I go over here and say I'm going to do a trace, and it comes from a ground pin, see, it automatically defaults to making the trace like 3 millimeters wide, because that's what I just defined. I'm going to hit escape there because I don't want to do a trace there. But of course you can also go back to selection mode. You can also grab a trace there, and you can actually tell it to either, you can go to properties, or sometimes there is a thing that listed there that says track size. In any case, you can see that it's a predefined width is 1 millimeter, because remember that's what I said, but you can override it here. Or you can click that and say use net class widths, and then you can select a net class from there. Anyway, this is, you can therefore override it. If I now say 2 millimeters, it would be wider, but that's not necessary because this is just a signal feedback input, and it doesn't matter. But 1 millimeter is plenty for that. So I'm not sure if there's anything much else to say about that, how to lay it out. When you are done, you would actually plot them, and I usually do several plots. I do a negative and a non-negative one, often for reference, and I print them out just on paper. But to make the negatives, I use overhead projection film, clear film, or you can use vellum. I've used that as well, that works too. You do have to be aware that when you do that, that some of the film is actually doesn't allow ultraviolet light through, so it may not work. But the standard stuff that I bought just from Amazon, which you'll see when we get to it, actually seems to work. So just a note of warning there, that if it doesn't seem to work, maybe that's the case. Ultraviolet light is being blocked by it or something. In any case, so I do a plot for the front CU, and I'll do it mirrored. I'll do it negative because we got the photoresist that we use is actually a negative photoresist. So in other words, where the light hits it, it hardens, and that is where the copper stays. If you have a positive resist, which was available in years past, but I couldn't find any in my recent searches, then of course you wouldn't have to have a negative plot. But in any case, this is what we have. So we used a negative plot, and there's a few settings here which actually are not important for the when we're doing this particular plot, when we only have front CPU selected. So then you can just say plot, and it's very quick. It has created a file in the actual project folder called dot f underline CPU cu rather PDF. I also do a plot on the fab layer, and there we don't do a negative plot, and I do two of them, a mirrored one and a non-mirrored one, because remember we're putting some of the components on the other side, and it's handy to have two of them. And so I would just hit plot again. I'm not going to do it because I've already done it, and I'll show you what you get. Okay, so at that point we have created the PDF file. If you didn't notice, actually I don't know if I showed you there, you have to select PDF here. Don't select any of the other ones, because for homemade ones it won't work. If you are using a PCB maker, then they will want Gerber files. If you're going to use some sort of machine in order to machine it out, you might want an SVG file. I haven't tried any of those things. I do have a machine to do that, but I think that using the photoresist and some ferric chloride works so well that why would you want to bother trying to grind the copper off the board? It doesn't usually come out all that well anyway. So yeah, so make sure you select PDF. So now we can actually close that. It'll say, do you want to save it? Sure. I don't know what I've done, but save it anyway. Same here. And close this. And then we can actually bring up. So I open up the File Explorer here, and you'll see there is the file we just generated. And let me open that. I have a proper PDF viewer, but I will open it with the let's say Firefox. So there it is. That is what the PCB is going to be looking at. And don't forget, this is negative, so wherever it is white you're going to have copper, where it is black there's going to be no copper. And I can actually show you on the camera here what they look like. Let me open that up for you. So here I've got them printed out on some paper. This is what the negative's going to look like when we print it on the foil. And I also printed out, as I said, those fab ones, and they actually show where the components are located. So from the bottom view it would look like that, and from the top, the copper side, it would look like that. So it is actually, as you can see, it's a mirror image. That's why I print out a mirrored one and a non-mirrored one. And so if you overlay this over here, it's actually like this. If you overlay that over here, well, let's turn this around so it's proper way up. You can see how the components go. There's two capacitors here. There is a fuse there. These are the outputs or inputs. There is a resistor there. Those two pads. The actual diode is over here. Goes between there and there. It's sometimes a little bit tricky to remember where the actual components go. Like for instance this one over here, which is actually this one. Its actual size, as you can see, would actually go over here, which may not be immediately obvious when you look at the traces. So that reminds you where it goes. See, shows you where it goes. It's there, and that goes over there. Now another reason that I print this out on a piece of paper first, let me see if I get that camera a bit straightened out. There, that's better. Is that this gives me an opportunity before I actually make the proper negatives to see if everything fits where it is supposed to go. This little capacitor here, let me put this next to it, maybe you can see both. That's better, yeah. You see why I'm using this. Where does this capacitor, this is a surface mount capacitor, where does that go? It goes over here, so I can see, oh, that's right, and it goes in that direction, so this is going to fit over here. And this is going to be the fuse. It'll be fine, the pins there. This is the actual diode, which would have to go over here. And I don't have the other components laying around. I have the surface mount resistors ready. I can just take them out when I'm ready to solder them on. I know that they fit in the allocated like this. There's one here, and which is actually, this is a capacitor. Now what I've actually done, yeah, there's one here. What I've actually done is I've used some true hole 100 nanofarad capacitors here for the simple reason that I got a ton of them and I can use them. You see over here there is this capacitor, and between the legs of the capacitor I was able to route a trace. If I use a surface mount one, it would have been over here, and I couldn't do it as easily. So sometimes the decision to use a true hole component might be because it's more convenient for the routing of the traces. I've already checked the size of the holes for the true hole capacitors, and the inductors I know work as well, so I've really done that. But you know, you would actually do that as well. So once you've worked out that the layout is working and this is a real size of the board is going to be, then you can actually print it on the foil, which is what we're going to do next. Let me put this away, and we were going to go and get the foil. Okay, this is the transparency film that I'm using. I got it from Amazon. Nothing special about it. It's just some clear sheets. The shop dog is here in case you're wondering what that geez, doesn't know what's going on. Okay, so we're going to be using this sheet over here, and I'm going to set that up right now. So I'm going to turn the printer on. Okay, so we are ready now to print our negatives on some of that overhead film, and you can use any of the PDF readers. This particular one here allows me to go to print, and I have a Brother printer, and I will set some settings here. Scale none is what I want. Properties, we actually are in landscape mode. And print setting, graphics, yeah, fine. Multiple page, we don't want multiple pages. And there should be some advanced, no scaling, and other print options. Density adjustment, we actually want the darkest that we can get. Improve print output, improve toner fixing. Your printer, if you've got a laser printer, might have different properties that you can set. And I'm going to say OK, and I'm going to say OK, and now I'm going to put the film in the printer, and when I get back I will push the print button. Oh, and what I'm going to do is I take a little Sharpie with me, and I make a little black mark on the right top hand corner that as I'm feeding the film in, and then I actually want to print a second copy on the same film, but I want to make sure that it is not going to overprint the same thing. I want 2 copies of it, so by putting a mark on the film I know how to turn it over so it can print on the other side, which is what I will do. Okay, so I have 2 copies of this printed out, and as you can see, let me zoom in on there. The black portion of on this particular foil, on this particular laser printer, is not fully formed. It's a little grainy, and in my experience, when I just use this negative by itself, it actually is possible for some of the light to feed through, and then when I'm developing this thing, you can tell that it has received a little bit of UV light, and it becomes harder to develop. So that's why I make 2 copies, and I'm going to cut those out. So just give me a minute here with some scissors, and I will place one on top of the other. Now, if you have a better laser printer, or you have better foil where this doesn't happen, you wouldn't have to do what I'm doing right now, to print 2 copies and to stick them on top of each other. So keep that in mind, but you may or you may not have to. Okay, I have both negatives here. Now remember, we printed these guys in mirror mode because we want to use the printed side down. The reason we want to do that is we want the black printed sides touching the PCB with the photoresist on it so that no light can actually bleed through. Because I have found that even though this foil is very thin, if it is the other way around with the printed side up, there is just, there's maybe a tenth of a millimeter between the photoresist and the foil, and if you got very fine details, a little bit of light will still bleed through and you will lose some of that detail. So that's what we want. And remember that, where is our display capture there? So remember, that is what the circuit board looks like. And well, let me bring in the camera as well. Just hold on for a second here. Okay, so they're both on the screen now. This is the negative. Now I've got the negative sitting on my light box. This light box I built from parts from an old TV. And I have a video how I built that, two-part video. I think if you're at all interested, you can look for that. In any case, so you see that this is how we laid it out on the on KiCad, and this is going to be the top layer of the PCB. So as you can see, I have the printed side down, and you see the actual negative over here is oriented the right way. So that is correct. So let's get back now just to the camera. Alright, so I'm going to put a little bit of sticky tape here underneath, just on the black part. Oh, sorry, it'll be off the camera for just a second here. And I'm going to take some scissors here, and I'm just going to cut that off a little bit, so it's just, I don't want it getting onto the clear part. And then we line up the two negatives. If you don't have a light box, you can just put it against any light object. Even during the day, you could even hold it against the window, and the light is shining through the window. So let me have a look. One of the reasons that I put the outline on is that it allows you to see if it is accurately lined up. It's actually easier to do when I'm holding it, so. Okay. So if I hold it down, as you can see, it is nicely lined up now, and you can tell with the little white line that's on the outline there, that shows you that it is lined up good. Now I'm going to put some tape on the other side. Very good. So the next job is to get some piece of PCB board and mark off the size, cut it to size, and put the photoresist on. Okay, so it seems that the negative fits exactly on the PCB in this direction here, which is good because we won't be wasting any. And the actual size is 4.8 millimeters, centimeters rather. So we can actually put a couple of marks on here. Like that. And then I can take the ruler here and connect them together. And now I'm going to take it to the bandsaw. And we're going to cut it off. So stand by. Alright, so we have this cut. The small, slightly smaller size pieces is what we need. There we go, fits nicely. So now we put the negative aside and we're going to put photoresist on this so it can dry. I'm going to actually let it dry overnight. It's 4 minutes past 12 midnight, time to go to bed. But I just want to finish this before I shut down. So let me get the equipment. First things first, we're going to clean this off with some isopropyl alcohol. It has fingerprints and all sorts of stuff on there. Okay, that should do it. Okay, so I have some double-sided sticky tape here that I'm going to put a little piece on there, just in the middle here. And this is an old envelope. I'm going to stick it down. Okay, it's stuck to the envelope, so it's not going to move around. Now what we use is little rollers. This is a, let me zoom out a little bit so you can see better. I bought this one here on Amazon. I call it the brayer roller. It's used for inking. And I have this little one here, which was actually originally for spreading glue for woodworking, but it works same way. And I'm planning to use the little one because this is a small PCB. Now, in the past, normally I've been putting the glue straight on here and just rolling it on, but I'm going to try something different today. I'm actually going to do it like, I'm going to ink it like printers used to. I've got some glossy paper here, and I'm actually going to put some of this photoresist. Now the stuff that I'm using, you will find it in the description if you want to purchase this kind of stuff. And I'm going to get the roller inked up. I want a very thin, even layer on this PCB. This photoresist, when it is cured, is very hardy. You don't need much, and in fact a thin layer is preferential. There is a hair on there. The dog has been visiting and now there is hairs everywhere. Okay, you can see the mark there. There's still another hair on there. There it is. Boy, there's hairs everywhere. The dog must be molting. Okay. Okay, that's good. See, this way, by spreading it first on a piece of paper, and I'm using glossy paper so it doesn't absorb it, put a nice even coating on the roller, and then you can roll a nice thin coating onto the PCB, and in fact you should be able to still see the PCB a little bit through, to be a little bit translucent. That's how thin a layer you want. If you make it a thicker layer than that, you will find that it takes a lot longer to develop, and there's just takes more time and it takes longer to dry. Okay, so this is as far as we're going to go. This is the tune it in a little bit. That is the photoresist. I got 2 little jars for just a few dollars from China. I can't read Chinese, so I don't know what it says, but it is working very well for me. Okay, so now the rest of it we will do in part 2, where we actually create the PCB. So I will see you guys in the second part, and as I always say at the end of these videos, please subscribe and like and all that kind of stuff, and I will see you guys next time.